Hello, welcome to ACT Math Part 1. I'm Doris Ann Mertz, and I'm going to try to help you review some of your math facts and formulas and do a few exercises, problems with you to get you ready for your ACT math test. The material that I'm using in this PowerPoint comes from various sources, including the Learning Express Library ACT tutorial, the ACT Prep Black Book by Mike Barrett, the Princeton Review Crack the ACT book, and my favorite one of all, the one that I like the best and recommend if you're only going to get one book, is the College Panda ACT Math book. Also used various internet sources. They'll be credited at the bottom, and access some previous ACT tests at crackact.com, which I recommend. I recommend that you practice for the ACT math test with only real ACT tests from prior years and to get you really ready for it. And you can find some of those at crackact.com. All right, let's go ahead and get into this. There will be 60 questions on the math test, and you'll have 60 minutes to do them then. So that gives you 1 minute per question on average, but you're going to want to go faster on a lot of the questions on the ones that you can, so you can have several minutes for the few time consuming ones that you'll have on the test. So you're going to probably have to skip some that you don't remember how to do. You're not going to probably get them all right, but I just wanted to encourage you by telling you that if you get half of the questions right on your average ACT test, they're all kind of curved differently, but if you got 30 out of 60 right on your average test, you would score a 21, which is the national average for the math test. If you got 3/4 of them right, then you would score a 28, which is a pretty decent score. So don't be beating yourself up when you get questions wrong. Just keep moving on, get the ones right that you can. So the object is to just get the most questions right in the amount of time that you're given. All right, here's some tips. It's important to review your math facts and formulas, just like on the ACT English, where it's important to review your grammar skills. It's important to review your math facts and formulas. That's the opposite of the science and the reading test. It really doesn't do you any good to review things you've learned in school. You're just going to have to learn some strategy and some pacing to do well on those. The math test time management is important. You can use less than 1 minute on many of the questions, which are easy questions. And sometimes the answer is often easier than it looks, and you can avoid unnecessary calculations by, looking at some clues in the answer choices or figuring it out without, putting pen to paper or getting to your calculator and stuff. So there are going to be hard questions or time-consuming questions, so you want to skip those hard questions and come back to them later. You want to get as many right as you can in the time you're given, so you get just the same credit for an easy question as a hard one. So skip those hard or time-consuming ones. And make guesses if you are almost out of time. On this skip hard questions part, you want to do the now, later, never, just like in all of the ACT test. We talked about this earlier. Do the ones you can do now and they don't take a lot of time, just do them now. If you know how to do it, but it's going to take a lot of time, mark it, skip it, come back to it later. If you're never going to know how to do it, you have no clue, you can't even make an educated guess, just choose your letter of the day and go with that. All right. The questions on the math test appear in the order of difficulty, but the topics are scattered throughout the test. So this is unlike the other tests. But that doesn't necessarily mean that the ones at the end are going to be the hardest for you, because if the ones at the end tended to have more trigonometry in them and you are studying trigonometry at the time, that may be easier for you than remembering some of your pre-algebra skills. So next thing, make sure your calculator is an approved model. And this is very important. Don't borrow a new calculator you've never used. Make sure you are comfortable using your calculator. That's just as important as having an approved model. Well, you can't take the test if you don't have an approved model, but just make sure you're comfortable using your calculator and you're not having to figure it out and waste time while you're on the test. And here's a little thing that I've found, that some questions are answered more quickly without a calculator. Now, there are some that going to your calculator is going to save you time, but some you can look at the answer choices and figure it out without, punching a bunch of numbers in your calculator and using all that time. So make sure you look at the question and the answer choices. Let's talk about the test content. So 20 to 25% of the test will be pre-algebra, 15 to 20% will be elementary algebra, 15% will be intermediate algebra, another 20 to 25% will be plane geometry, 15 to 20% will be coordinate geometry, and 5 to 10% will be advanced math or trigonometry. So these vary on different tests, but I want you to see that a lot of the test, almost half of it, 40 to 50%, comes from pre-algebra and plane geometry. So you really want to focus on reviewing pre-algebra and plane geometry. You want to know your basic formulas. You want to know your area of squares, rectangles, circles, triangles, know those backwards and forwards. You want to know how to use the Pythagorean theorem. You want to know how to figure slope and distance and things like that. And you want those to be right there ready where you don't have to do a lot of time trying to remember them. You got to have them handy. If you're not sure of an answer on the math test, then you can eliminate some answers and guess, just like on any other of the tests. And sometimes you can look for easy solutions to difficult problems. So instead of actually working the problem out, the answer is in front of you. It's a multiple choice test. So sometimes it's quicker to just plug in the answers and see which one is right. So you'll have to decide when to do that, but sometimes that is a strategy you can use. These are some of the Black Book's unwritten rules. And one is that you must know the words and symbols. So you have to know what the question is asking about, know the symbols, understand what you're being asked to do. You don't have to memorize advanced formulas. I told you you do have to memorize, the area of circles, triangles, things like that. But like the area of a cone or a sphere, you're probably not going to have to memorize that. There may be a question about that, but there'll be a note that tells you that formula. There's usually at least one note question on the test. A lot of times it may be about trigonometry or something. It'll be a more advanced question and it'll give you some information in a note. And usually if there is a note, usually you do have to use that information when solving the problem. Most of the calculations are relatively simple. It's made that you could complete it even if you didn't have a calculator. So it's not super complicated math. And I mean, the calculations part is not very, involved. The calculations part aren't. It's limited in the subject matter. It doesn't really go past trigonometry or some basic logarithm, basic calculus. You have on a lot of the questions, you can answer them in 30 seconds or less. It's not going to take you a lot of time on some of those, and you'll need to bank that time to use on the harder questions. All the necessary information is provided on the test in that question. I'm not saying the formula is, but there's going to be enough information, like if there's a drawing and you're having to figure something out, there's enough information there to figure it out. And here's an important thing. This is different than the SAT. Scale is usually accurate on the ACT. So you can usually count on the scale. You can count on the scale to be accurate. You don't have to worry about them drawing a drawing that is to throw you off. Now, I'm not saying that there may be questions where it looks like you've got a right angle, but don't assume it is a right angle unless there's that little square that signifies it's a right angle. So don't make an assumption that it's a right angle unless you see that little square, but scale is usually accurate. Answer choices are important on the ACT and can give you a clue as to what to do. So let's get right into some review. We're going to, in this first section, talk about some of your basic algebra. We're going to go over the order of operations. If you remember PEMDAS, we're going to go over that. We're going to talk a little bit about mean, mode, and median. We're going to talk some about exponents and how you do those. We're going to talk about FOIL. If you'll remember, that's first, outer, inner, last, and the difference of squares. Difference of squares can save you some time on the ACT, and time management, as we've mentioned, is important. All right, PEMDAS, the order of operations. So just remember to do operations in this order. What's in parentheses first, exponents second, multiplication and division from left to right, and then addition and subtraction from left to right. All right, mean, median, mode, and range. You just need to know what these mean. Mean is just the average of numbers in the set. The median is the number that's in the middle If you have an even number of numbers, you'll just have to take the middle two and average them to get the median. The mode is the most frequent number, so it's just a number that shows up the most often in the list. And the range is the difference between the highest and the lowest number in the list. Now, this is important. You're going to really want to review your exponents and roots and powers to do well on the ACT. You need to have these down pat, and we're going to review some of them. When you are multiplying exponents, you just add the exponents together. So if you're multiplying exponents, you add the exponents together. And in this case, when you're multiplying by the same exponent, then you can make ax times bx. It can turn into ab to the x power. When you're dividing, I'm sorry, I should have went here next. So when you're dividing exponents, you do the opposite. You subtract the number in the denominator from the number in the numerator in the exponent field. And if you are raising an exponent to another exponent, you are going to multiply. So a lot of people make the mistake of multiplying here. You don't. When you are multiplying numbers that have exponents, you add them. But when you're raising an exponent to another power, that's when you multiply the exponents. We already did number 4. In number 5, when you have a over b to the x power is the same as a to the x over b to the x. Any number to the 0 power equals 1. If you have a to the negative x, that's the same thing as 1 over a to the x. So 1 over a to the x is the same thing as a to the negative x power. This also will come in handy. A to the p over q, you take the numerator and you put it under the radical sign. So it's a raised to the p power, and you take the qth root of that. So the denominator ends up outside the radical sign and the numerator ends up inside the radical sign. It's also important to know how to get rid of radical signs because you can't leave them in denominators. So if you have the square root of x equals b, that's the same thing as x equals b squared. You could square both sides to get rid of that radical sign. If you have the cube root of x equals b, it's the same thing as x equals b cubed. If you have if you're taking the nth root of x, you can write it in a different way and say x to the 1 over n power. So if this was, you're wanting the third root of x, you could write it as x to the 1/3 power. So you want to really get those exponents down pat. Let's do some practice. For all non-zero values of x, 12x to the 6th minus 9x squared over 3x squared equals. So our answers all, we've gotten rid of the denominator in all the answers, so we know we're going to get rid of the denominator here. And so what you're going to do is just divide 3x squared into this numerator. So we know we'll just go as far as we have to. We know that 3 goes into 12 4 times. All the answers have a 4. We know that x squared goes into x6. If you remember, when we're dividing, we subtract the exponents. So 6 minus 2 equals 4. So we've eliminated a and b. So we know it's 4x4, and then it's a minus. And then not 3x squared goes into 9x squared 3 times, because you're going to get rid of the x squares. You're going to cancel each other out. 3 goes into 9 3 times. So your answer is going to be E. All right. Now, that was a simpler exponent problem, but sometimes they're more complicated. Here's one. So even though exponents is algebra, and you might think, well, that's going to be at the beginning of the test, it can actually be, used in a difficult question. And as you'll see, this one comes near the end of the test. It's actually number 56. So whenever j and k are positive integers such that the square root of 3 to the j power equals 27 to the k power, what is the value of j over k? So to solve this one, you're going to have to remember that when your base number is the same, like if we can get these two base numbers to be the same, then we can set the exponents equal to each other. So that's what we're going to have to do to solve this problem. So let's work it out. All right. We've got the square root of 3 to the j equals 27 to the k. So we're going to change that to get the 3 to be our base. So If you'll remember, we said square root is the same thing as 3 to the 1/2. So we've got 3 to the 1/2 raised to the j power, and we're wanting to make this a 3 too. So we've got 3 raised to the 3rd power. That's the same as 27. So we got 3 raised to the 3rd power, and we raised that to the k power. So let's assign those, and that gives us the 3 in the base, and the j, the half raised to the j power, that's going to give you j over 2. And you multiply here because you're raising the 3 to the k power, so that gives you 3k. So we're going to set j over 2 equal to 3k. So we're going to multiply by 2 on both sides to get rid of the denominator, and that gives us j is equal to 6k. So when we put 6k in the top in place of the j, then we're going to end up with 6. So the answer is K, 6. So because J is equal to 6K, 6K divided by K equals 6. All right, let's solve this one. For all non-zero RT and Z values, what is the answer to this? It's just another simple one where we're using our rules of exponents. So let's work it out. We've got 16r to the 3rd. I'm not going to read all that. Anyway, we're going to take the 4 and put it into the 16, and that's going to go into that 4 times. We're going to take the r and put, since wherever the number with the largest exponent is, that's where the base is going to end up. So 3 is more, and the r down here is raised to the 1 power. So 3 minus 1 is 2. So we're going to have an r squared in the numerator. Now in this t part, t to the 3rd is more than t, so the t is going to end up in the denominator, and it's going to be 3 minus 1, so we're going to have t squared in the denominator, and in the z part, we're going to have a z raised to the 3rd power in the numerator. So our answer is 4r squared z cubed over t to the 2nd power. All right. We're going to talk about FOIL a little bit. You use it when you're solving a polynomial, and FOIL stands for first, outer, inner, last. This is a polynomial where you have x plus a multiplied by x plus b. So to do the first, we go x times x is x squared. The outer, we get b to the bx, and then we do the inner, and we get ax, and then we do the last, and we get ab. Then when you combine those two, usually there's numbers here, and so you're going to have x squared plus b plus a times x plus ab. So that's how you use FOIL. And sometimes you'll use reverse FOIL when factoring if you can, if it comes out even. So in this case, you'd put the x, you put an x out here, they're both going to be pluses. If this one is a plus, both of these will be the same. And since this one is a plus, it's going to be 2 pluses. Now, if this had been a minus, these would both be minus. If this had been a minus, then we'd know that one would be a plus and one would be a minus. So anyways, we got to figure out 2 factors of 15, and those 2 factors of 15 have to add together to make 8. So we're going to end up with x plus 5 times x plus 3 equals 0. Now 5 and 3, when you figure out those factors you need there, those are not your answers. Your answers are found when you set x equal to 0. So it's going to be -5 or -3. Right, difference of squares. I told you to remember this one to save time. So anytime you have a square minus b square, it's going to be equal to a plus b times a minus b. Now, you might use this because you have a denominator that has a radical sign, and it says a minus the square root of b. And one way you get rid of that is multiplying that a minus the square root of b times a plus the square root of b. And that would get rid of your radical sign, and it would give you like a squared minus b. So that's a good one to remember to save you some time. Let's look at this problem. For all positive values of x and y, the radical expression square root of x over 3 times the square root of x minus the square root of y is equivalent to which? All right, so what we're going to have to do in this one, we're going to have to get rid of those radical signs in the denominator. So we're going to multiply, we're going to use our difference of squares, and we're going to multiply that to get rid of these radical signs. We're going to multiply it times 3x plus the square root of y. So we have to multiply it by 3x plus the square root of y over 3x plus the square root of y, because that's the same thing as multiplying it by 1. And when we do that, we get on the top, we get, let's just look at the answers over here to save us some time. We'll use this as a time to learn about how to save time. We know that our answer on the bottom is going to be 9x minus y. We're getting rid of those radical signs. So 3 times square root of x times 3 times the square root of x is going to be 9x. And the difference of squares, we know that the last part is just going to be minus y. So we look in our answer choices over here, and there's only one that has 9x minus y in the denominator. So, you know, you're crunching for time. You may go that far. No, it's C and circle C. But if you did distribute this at the top, you would find out that you get 3 times x plus the square root of xy, and that is also the answer there on C at the top. So C is the answer, but you could have found out this one probably without going all the way. All right, thank you for watching this part 1 of the Math ACT, and I'll share some more in part 2.